So this is the solution for the problem path sum 2. It's labeled medium, but it's actually a really simple problem. All you need to do is know how to implement DFS correctly. I think the solution itself would make a lot more sense. So let's dive into it. First, we need to know what the answer is. So I'm going to store it as object variables as an self.ans, just because it will make things a lot easier when we write DFS in another function. Let me write it like this. Cool. We're going to have answers in self.ans, and at the end, we're going to return this variable. What else do we need? Again, we'll need self.targetSum because of the similar reason. I'm going to check both of these when we're doing DFS. So instead of passing both of these variables, it just makes a lot more sense to have them as variables like this, self dot. Cool. What else do we need? We're going to also call DFS function itself and pass it the root. Now the DFS function itself will actually contain three variables. We'll work on three variables. One of them is the current node. One of them is the path. This is the path we're going to store in the answer if the condition of path sum is met. We'll also store path sum. I'll explain what it means in a second. First, let's check if the node itself is not present. If it's a none node, in that case, return as is. We don't want to bother about it anymore. Okay, now what? In the current, okay, what are we taking path as? If you look at the answers here, is going to be a list of lists. Each of these lists is a path. So this path naturally makes sense to be a list where we'll append the current node's value. At the end, we'll also want to pop it out from the list uh, because this is the part where the backtracking comes into play. Cool. What else do we need? We also want to update the path sum. So we'll write path sum plus equals to whatever the current node's value is. You may also ask, why do we need path sum and path separately? Why can't you just write it as the sum of path? And that's because passing it as a variable is more efficient rather than storing it or rather than computing it at runtime, which will again take order of n time if there are n nodes that were taken into consideration for the path. Okay, so we'll instead have another variable just to store that. It's not much time, and the stack will take care of itself. So we'll have path sum here. What else do we want? We now want a way to say that if the current node is a leaf node or not. See, because the question hinges on this particular property, which says root to leaf paths. Now, only if it's a leaf node, then we want to consider if the some path sum is equal to the target sum. Let's actually do that. Now, if some condition, we'll go ahead and do the normal compute, treat it as a normal node, or in case if it's not a normal node, we want to check if the path sum is equal to the self dot target sum. This is where instead of passing target sum each and every single time, having self dot is much more efficient. Cool. What will happen if that is the case? Just add it to the answer. I'm going to append the path to the answer, but note that path itself is going to be passed by a reference. That means a slightly different thing in terms of Python's object. By Python deals with objects differently, and this reference isn't exactly passing by reference, but it's you can think of it that way. So instead, we'll just have a copy of this array, of this list that will store in the answer. Okay, what is this condition in the most general case when it's not a leaf node? How do you define a non-leaf node? It has nodes to the left and the right to it. So if left or node dot right, it means that it has a child in either the left node or the right node. So both of them are fine, but that is not a leaf node. Okay, what if that is the case? If that is the case, then I'm going to call the DFS again, and this time we'll send the node dot left along with the path, which is now updated, and the path sum, which is also updated. At the same time, what do I want to pass? I want to have node dot right again. Again, you don't have to worry about the case where the say node.right is none and node.left exists. In that case, we'll handle it right here, and that won't be an issue in implementation at all. So the one thing that's now left to do is edit this guy, and we'll have the path start out as empty path, and then path sum start out as 0. Okay, uh, let's go ahead and try this. Cool, looks like it's being accepted. So we'll just go ahead and submit this. There we go. Okay, 90% faster and 88.82% beats memory usage. Pretty cool. Again, it's just an implementation of DFS. We do need to keep care of this path.pop here because of the backtracking thing. But other than that, uh, it's very simple implementation of DFS. That's it. Cool. I hope this helped you. If you have any comments or discussions you want to start in the comment section, please feel free to do so. If this helped you, drop a like or leave a comment saying that this helped you. And if you have any more good questions, medium to hard level, I'm more than happy to attempt them. That's it. Thanks for watching.